Welcome to the second part of our solution. So in the last video we simulated our selection process one time, and in this video we want to simulate our process many times. And as we are here in the NumPy solution, we want to do this in a vectorized manner. So we will operate with vectors and matrices, so to say with the 1- and 2-dimensional NumPy arrays. Alright, so let's start, and first of all we have to import NumPy as always. And then we are starting with a toy example. So we have 10 applicants and our test group size is 5. And we want to have the best prints in the test group as our reference prints, and we use 10 simulations. And we already know for one simulation that we can create 10 prints with the quality 1 to 10 with the np.arrange method. So here we get an array from 1 till 10. And now as we want to have 10 simulations, we need our array here 10 times. So we need actually a matrix where each row is actually a simulation. And for each simulation we have 10 columns, which stands for 10 prints. And therefore we can use the np.resize method. So let's check here with Shift Tab. So np.resize returns a new array with the specified shape. So first of all we pass here our one-dimensional array with the integers 1 till 10, and then we have to define a shape, the new shape. And it says here if the new array is larger than the original array. So our new array should be a matrix with 10 rows and 10 columns. So our shape should be here 10, 10, so 10 simulations and 10 prints per simulation. And now it says here if the new array is larger than the original array, so this is the case. A matrix with 10 rows and 10 columns is larger than a one-dimensional array with 10 elements. Then the new array is filled with the repeated copies of A. So A is here our array. And let's try this out, and we assign the variable m for matrix. And here we can see that we get actually our array with 10 prints 10 times. So here we have 10 simulations. And as we have a random order of the prints, we have to randomly shuffle each row here. And there's actually no function that can do this in a vectorized manner. So there are some complicated solutions where we do not need actually a for loop, but they are quite complex and quite slow. So here, in this case, we have to use a for loop. And first of all, we set our random seed to 1, 2, 3. And then we iterate over the amount of simulations, so we have 10 simulations. And for example, for the first iteration, where I is 0, we slice our matrix for the index position I, which is 0. And by doing so, we get here the first row at index position 0. So we get here this row. And we actually shuffle the row. And then we go on to the next iteration, where I is 1. So we select the second row at index position 1 of the matrix M. And we shuffle also the second row. And we are doing this for all rows. And as np.random.shuffle does this in place, we do not have to assign a new variable. So we actually shuffle each row and get a random order for each row here. So let's try this out. And let's check M, our matrix. And here we can see that for each row we have actually a random order. So here in our first simulation we are starting with prints with quality 5, and we are ending with the prints with quality 3, and so on. And now we have to split our matrix for the test group and the select group, or to say for the test matrix and the select matrix. And therefore we slice our matrix M, we take all rows, and we're actually slicing for the first 5 columns, starting from index position 0 until index position 0, 1, 2, 3, 4 including. So the first 5 columns. So we are creating here a new matrix with the first 5 columns, and we assign the variable test matrix. And let's also check this. So here we can see we have sliced our matrix M. So we sliced it here actually. So here in our first row we have 5, 1, 8, 6, 9, 5, 1, 8, 6, 9. So this works. And then we have to sort each row from high to low or low to high, and we can do this with the sort method. And the sort method works in place. So let's check our test matrix sorted. And we can see that we have sorted each row in an ascending manner, so starting from the low values until the high values. And now we can slice our test matrix for the highest values or the second highest values by slicing for all rows and then taking the column at index position, for example, -1. So if we want to select for each simulation the best prints in the test group, we select for the column -1 and we get this here. So let's try this out. So here, as n best is -1, we select the very last column, 9, 9, 9, 9, 10, 10, 10. So you can see here, this is the same. And then we have to define our select matrix, and we simply have to slice our matrix M here for the last 5 columns. And we can do this by slicing for all rows and then slicing from column at index position 5 until the very last column at index position 9. So here we get the select matrix, and let's also check here. So it's starting here with 4, 8, 5, 10. Let's check our matrix. So we splitted it here, 4, 8, 5, 10. So it worked. And now we have for our 10 simulations our select group. So we have here for the first simulation our first select group, for the second simulation the select group, and so on. And here we have the reference princes for all simulations. So for the first simulation we have 9. Now we have to compare all princes of our select group if they have higher quality. So we have to compare here 4 and 9, 2 and 9, 7 and 9, 10 and 9. So 10 is better than 9, and in our very first simulation we would select actually Prince Charming with the quality 10. And in the second simulation, first of all, we have to compare 8 and 9. We have to compare 7 and 9, 10 and 9, and also in the second simulation we select Prince Charming. So let's go to the fifth simulation, so 1, 2, 3, 4, 5. So in the fifth simulation Prince Charming is already in the test group. And let's go also here to the select group of the fifth simulation, so 1, 2, 3, 4, 5. And we can compare here all elements of our fifth simulation, but we do not find any prince that is actually better than Prince Charming. So here for our fifth simulation we should get the result 0. Alright, so what we actually have to do, we have to compare here each element of our test matrix best with the corresponding row of our select matrix. And there's actually, at least from what I know, no efficient way to do this in a vectorized manner. And therefore I introduce here a for loop. So let's do this step by step and include here a line, and then we copy here out the first part here of our code. And in the very first simulation I is 0. So what we are actually doing here in our very first iteration, that we actually compare here all elements of the first row of our select matrix at index position 0 with the first element of our test matrix best here, also at index position 0. So we compare actually whether 4 is greater than 9, 2 is greater than 9, 7 is greater than 9, and so on. And we get here a false, 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 true, false. So only for 10 we get a true here. And now in the next step we should filter for all elements in the first row where we get a true here, so in this case 10. And therefore let's copy here this part. So we take here the first row of our select matrix. And now we include here spare brackets. So we only filter here out from the very first row the elements where we get a true here, and it should be 10. Here I have to put here 0 of course, so now. And again here we have to append the element 0 at the very end of our array, so then it also works and we do not get an error message for the case that our array is here empty, because the best prince is already in the test group. And then in the very end we actually select our first element, so the very first prince that has higher quality than the reference prince. And we are actually doing this for all simulations or for all rows. So that's actually all. And let's try this and print out all princes that we select here in our 10 simulations. So in our first simulation we select Prince Charming, also in the second, third and fourth. So we have 10, 10, 10 and 10. And then in the next 3 simulations we select the no prince here, because we already have Prince Charming here in the test group, and so on. And instead of printing here our selections, we can also store our selections here in a NumPy array. So first of all we create an empty NumPy array with 10 positions. So we have 10 simulations and we want to have a NumPy array with 10 results. And we assign the variable results. Then we iterate over all simulations. And for example, in the first simulation, we store our selection of our first simulation in our results array at index position 0, so at the first position. Alright, so let's do this. And let's check here our results array. And no surprise, it's actually the same as above here. So 10, 10, 10, 0, 0, 0, 10, 0, 10. And let's again collect our whole code. So here in the first cell, we have our variables. So we have 10 applicants and the test group size is 5, n best is 1, and we have 10 simulations. And here in this cell, we merged the code from above. So we created a matrix. Then we shuffled all rows of the matrix. Then we sliced for the test matrix, we sorted the test matrix and selected in this case the best princes for each simulation, and then we sliced for the select matrix. And then we compared our select matrix with the test matrix best, and we stored the results of all simulations in the array results, and then we print our array. So again here no surprise, we get our array with 10 results. So 6 times we get Prince Charming and 4 times we get no prince at all. And apparently our toy example works, so we can now go to our princess challenge where we have 100 applicants. And our first naive strategy to have a test group size of 50. Our reference prince is here the best prince in the test group, and we want to have 1000 simulations. So here's our code, and it should also work here with our new parameters. And in the end we print here our results array with 1000 results of 1000 simulations. So we can see here a lot of hundreds and zeros and 99s. So we are finished now with this video, and we have successfully created a code that produces many simulations, that simulates our selection process many times. And in the next video we are going to analyze here our results array where we have 1000 results. So hope to see you there. Bye!